Hey guys, it's Mr. Calderon with Queen My Pawn. I'm going to be discussing SOHCAHTOA and just exactly what that means, when to use it, and how to use it. I'll begin by sharing my screen on my tablet and drawing from there. So, whenever you have a right triangle, such as the one over here, and we're basically assuming that's a right angle, usually when you have two sides like 3 and 4, you can use the Pythagorean theorem a squared plus b squared, in this case 3 and 4, to find c, but this is c squared. So 3 squared plus 4 squared will give you 9 plus 16. In other words, 25. But this is c squared. So c squared equals 25. Therefore, c must be 5. Like we said, c squared equals 25. So c must be 5. So this is why we have 5 squared here. However, let's say you don't know two sides and you're only given a certain piece of information or two pieces of information. That's the least that you need to solve a right triangle. You need two pieces of information. You either need two sides or a side and an angle. So let's say that we know this side. Let's say that this side is 6. And this angle is, let's say it's 60. Well, what is x? You can't use the Pythagorean theorem to solve this because you need two sides. But what I'm about to show you right now will allow you to solve this. So first, we need to consider, and we'll come back to this problem, by the way, the exact same problem. So that is not what I want to do. And that's interesting photos right there. So what I want to do is show you this triangle. So right now, consider the angle where my finger is, okay? So you can see the crosshair right there. And look at that angle. Okay, see how it's super small? And that makes the opposite side of it really small as well. Well, basically, as the angle becomes 0, you have no opposite side. But as the angle gets bigger and bigger and bigger, you can see that the opposite side literally starts to increase. You can see it increasing right before your eyes as the angle gets bigger. And as the angle gets smaller, the opposite side gets smaller until it becomes non-existent. So what does this all mean? Well, when we have an angle right here, we want to consider the opposite side. And we want to consider the hypotenuse. As, we'll call this angle theta, by the way. As theta goes to 0, we saw that the angle was getting smaller. The opposite side will also go to 0. Now, here's where I introduce SOHCAHTOA. A ratio is a comparison between two things. Here, let's compare the opposite and the hypotenuse sides. So if we have opposite over hypotenuse, as the angle becomes 0, obviously this will also become 0. We call this ratio opposite over hypotenuse, we call that sine of the angle. That's why we have SOHCAHTOA, to remember this. And we're going to go over the other ones in a moment. But SOHCAHTOA, we're here first. Sine is the opposite over hypotenuse. Again, let's look at the triangle and consider the opposite side again and the hypotenuse. So, no pun intended, by the way. Okay, ignore that triangle. Oh, okay. So right now the angle is 0. the angle keeps getting bigger and bigger. And see how the angle gets bigger, the opposite side gets bigger? Let's make the angle even bigger. Now the angle is getting super, super big. The angle's almost 90 degrees at this point. You can see that the opposite side is starting to look like the hypotenuse. So right there, the angle is 90 degrees, and basically the opposite side is the same as the hypotenuse. Therefore, as theta goes to 90 degrees, sine, or in other words, opposite over hypotenuse of the angle goes to 1. Why? Because the opposite and the hypotenuse are becoming the same. When you divide the same thing by itself, in other words, when you divide the opposite over the hypotenuse, when they're the same thing, you get 1. 7 divided by 7 is 1. 20 divided by 20 is 1. Mr. Calderon divided by Mr. Calderon is 1. So that's why you have these values right here in green. Sine of 0 equals 0, and sine of 90 equals 1. And it's basically the same reasoning with cosine. Now you should test this for yourself. Imagine that you're drawing a triangle like this. And look at the angle that's right here on the, the very right angle, okay? All the way to the right, the one that's really small, okay? Not the one where the crosshair is. Let me just start over, hold on. There we go. Okay, look at the crosshair and consider that angle. When the opposite side gets bigger, then you should consider what's happening in cosine and tangent. So in other words, you would decrease the adjacent side. And why am I decreasing the adjacent side? Well, remember that cosine by SOHCAHTOA is adjacent over hypotenuse. So look at that triangle again and consider that angle, okay? The one that I just drew. As we're making the adjacent side smaller, the angle is approaching 90. So cosine of 90, well, the adjacent side is basically beginning to not exist. It's getting smaller and smaller. Let's see it in action. Look at the crosshair angle. It's becoming bigger and bigger and bigger until the adjacent side is basically non-existent. And the opposite and the hypotenuse are the same thing. So that's 0. And look, cosine and sine are basically partners here. But kind of like anti-partners, like arch enemies. Sine of 90 is 1, but cosine of 90 is 0. And the opposite is true. Cosine of 0 is 1, because when the adjacent side equals a hypotenuse, there's no opposite side. Sine of 0 is 0. Okay? So those are important to remember. Now, what's tangent? Well, tangent is, you can either do one of two things. Tangent is either opposite over adjacent, which we already, SOHCAHTOA. Let's go back to SOHCAHTOA. You can see the tangent is opposite over adjacent. So let's see what happens to tangent here. Oh, by the way, the other way to know what tangent is this. Tangent of an angle equals sine over cosine of the angle. So either one works. You can do this or you can do that. All right, before I show you what tangent is, you should try to figure it out for yourself. Play with this image in your head. What happens when tangent of the angle, let's say that the angle equals 0, right? So the angle is like this. What is tangent? And when the angle is 90, what's tangent? You should definitely consider that before moving on. So try to pause the video now and think about it for a minute. You can unpause the video now. So right now, tangent, the angle is 0. Tangent says opposite over adjacent. The opposite side doesn't exist. It's basically 0. And the adjacent side, it exists. It's some number, not 0. So 0 divided by anything is 0. Opposite is 0. Adjacent is something. Opposite over adjacent, 0 over something, that's 0. Now, let's make the angle bigger. You can see that something special occurs here. The angle's becoming 90, and now the adjacent side's starting to not exist. So when you have tangent of 90, you get some number. Let's call it, I don't know, let's say it's 20, right? It could be any number. 20 over, well, obviously it'd be 0, right? But that's the thing. You can't really divide by 0. So I can't even write 0. Like the laws of physics won't let me write 0 here because I might break something in the universe. Seriously. Let me show you what this would look like. Gonna show you on Wolfram Alpha right now. And you're gonna see exactly what tangent of 90 will give me. So hold on a minute. As I pull up Wolfram Alpha. I'm gonna put in tangent of 90. And I'm gonna share my screen in a moment. There we go. So I'm gonna share my screen over here. And look what it gives me. It gives me an infinity with a mustache. Well, you can see it says complex infinity. In other words, this infinity is a special type of infinity, but what you need to understand from this is that you cannot divide by 0. Here's why. Consider 1 divided by 1. It's going to give you 1. 1 divided by 2 is going to give you half, 0.5. 1 divided by 3, 0.33. You can see that the number is getting smaller. But let's go the other way around now. 1 divided by 0.5, that's going to give you 2. 1 divided by 0.05, that's going to give you 20. 1 divided by 0.005 is going to give you 200. So you can see as we're going, the denominator is getting smaller, the result's getting bigger. And actually, you just did something complicated. You just learned your first rational function, which is 1 over x. We put that in there. And you can see right here from the plot, let's enlarge that. Let's see if it'll let me enlarge it. And see how and you can see that x is the denominator, right? 1 over x. As the denominator gets bigger, the result's gonna get smaller. But the more you go towards 0 on the denominator, the whole thing gets bigger until you get to infinity. And on the left side of the graph, you can see that the infinity is actually going down. So that's basically why you get a result where you cannot divide by 0. So that's SOHCAHTOA, and that's an introduction to SOHCAHTOA. Next, we're gonna apply SOHCAHTOA to figure out what the special angles are, which I can't say what they are yet because I'll spoil the whole video, but I will introduce them in the next video. So this is basically part 1 of SOHCAHTOA, and part 2 is coming up next, and you should definitely watch that to see how you apply SOHCAHTOA to triangles. So I hope you like this video and this introduction. Make sure to click the thumbs up button if you like the video. Subscribe for more content, and I'll see you on the next one.